So when it comes to getting the absolute best results out of artificial intelligence, your best intentions are, well, they're actually the model's worst enemy.
Yeah, it's really the ultimate modern paradox.
Right. I mean, think about that for a second. Because whether you are, coding a brand new application or outlining a marketing strategy or just messing around with image generators on your phone, you obviously want the machine to execute the vision you have in your head.
Exactly, you have a goal.
Yeah, so you try to be helpful, you give it careful, meticulous, incredibly specific instructions, and by doing that, you are like actively destroying the quality of the output.
You are. The harder you try to control that generation process, the worse the final product actually becomes.
Welcome to today's deep dive. We're dedicating our time today to unpacking just one single source.
Jeffrey Emanuel's insights on the overprompting trap.
Yes, exactly. And our mission for you listening is to fundamentally rewire how you think about giving instructions to AI.
Because we really have to unlearn those habits that are, secretly ruining your results.
Totally. Whether you're a veteran software engineer or just someone who's endlessly curious about how these digital brains actually function. So, okay, let's unpack this. Because the intuitive way we communicate with machines, the way that feels so logical to our human brains, is actually completely backwards when you're dealing with neural networks.
It really is.
And I have to say, looking at your background right now, it is perfectly setting the mood for this.
Oh, thanks.
Yeah, you've got this subtly shifting, hyper-complex, somewhat chaotic digital blueprint room going on behind you.
Yeah, I thought it was fitting. I mean, it represents the incomprehensibly vast inner workings of a large language model.
Right.
Because when we type a prompt into a clean, minimalist text box on our screen, we tend to think we are just passing a simple sticky note to a digital
I
assistant.
was just sliding it across the desk.
Right. But in reality, we are sending a highly disruptive signal into this chaotic, massive architecture of billions of neural pathways. And how that signal navigates that architecture and how we, inadvertently block it from finding the right path is really where all of our problems begin.
Okay, let's start with the really specific, highly visual example that Emmanuel uses in the source, because I think it perfectly captures this trap that we all fall into.
Yeah, the nano banana example.
Exactly, the AI image generation tool called Nano Banana. So the scenario is pretty straightforward. You have two different pictures of two different people.
Right, image A and image B.
Yeah. And you want the AI to take the clothing, the pose, and like the orientation of the person in the first image, but you want to replace their face with the person in the second image.
Which is a very common use case for these tools. You are basically trying to merge the context of image A with the core identity of image B.
So let's look at the conventional wisdom here. I mean, the logical human approach is to sit down and write this massive, highly detailed prompt.
Right, you want to cover all your bases.
Exactly. You specify every single thing you want to happen. You add rules like, make sure the generated image looks exactly like the person in the second image. You might type something like, the facial likeness must be instantly recognizable. And then, because we try to anticipate where the machine might mess up,
We start adding constraints.
yes, we think, well, the guy in the first picture has a beard, but the guy in the second picture is clean-shaven.
So we add that to the prompt.
Right, we type, if person A has a beard and person B does not, definitely do not include a beard in the final image. We just build this fortress of parameters around the request.
Which, I mean, from a human delegation standpoint, seems perfectly reasonable.
It feels totally necessary.
Uh-huh.
If I am delegating a task to, say, a human intern, being that specific prevents mistakes, it provides guardrails.
Exactly.
I would assume a machine needs those explicit parameters even more than a human does.
And that assumption is exactly what Emmanuel targets, because the reality of the AI's architecture proves the exact opposite.
How so?
Well, when you use that massive, constraint-heavy prompt, the result you get back is usually terrible.
Like, unusable terrible.
Pretty much, you end up with an image that looks like one of those cheap 2D face and hole apps from, the early smartphone era.
Oh, man. Yeah, where it's just a flat photo of your face awkwardly pasted onto, like, a dancing elf or something.
Exactly. The lighting is completely unnatural. The proportions are bizarre. and the skin tones don't match at all.
There's just zero artistry to it.
Right, because the AI technically followed your instructions. The recognizable face is there, the specific clothes are there, the beard is gone.
But it looks like a terrible Photoshop job.
Exactly. Now, conversely, if you just give the model a very short schematic prompt, something remarkably simple.
Like what?
Like literally just typing, make the person in the second pic so they're dressed like the person in the first pic.
Just that.
Just that. And the result is radically different.
You get a cohesive, realistic image. The lighting blends, the shadows actually make sense.
Exactly. Now, you might have to hit generate a couple of times to get the exact perfect iteration you want, but the underlying quality and the realism are just night and day compared to the highly controlled prompt.
So why does giving a supercomputer less information make it do a much better job?
Oh, to understand the mechanics of this, we really have to look under the hood at how these models process language.
Okay, let's do it.
At their very core, these models are designed to be incredibly accommodating. They are basically the ultimate people pleasers.
Right.
Every single word in your prompt is attended to by the AI. Every single word has a direct impact on specific activation states within the model's neural network.
Okay, wait, let's break that down for the listener because activation state sounds a bit abstract.
Sure.
We're basically talking about all the dials and switches inside that chaotic blueprint room behind you, right?
That's a great way to picture it. Think of the model's brain as having billions of tiny dials. Billions. And when you input a word, certain dials turn up and others turn down. This activation weight space it's incomprehensibly vast.
Right.
And what's fascinating here is just how radically the model's internal state changes based on a seemingly minor wording change.
Because of that immense size you mentioned.
Exactly. Emmanuel points out a really fascinating example of this in the source material. It's a specific prompt he uses for code review.
What does he do?
He simply tells the model to look at the code with fresh eyes.
Wait, just those two words? Fresh eyes.
Just those words. And it is shockingly effective.
Really?
Yeah, because it's not just a colloquial phrase to the AI. It taps into something very deep in the model's architecture. It actually acts as a gestalt-switch.
A gestalt-switch. Oh, like that famous optical illusion.
Yeah.
Where you're looking at a drawing and suddenly your brain flips from seeing a duck to seeing a rabbit.
That is the perfect analogy. By just piping fresh eyes, you flip the AI's entire internal routing all at once.
That's crazy.
It physically toggles the model from a basic accommodating, builder mode into a deep analytical critique mode.
So just a few carefully chosen words change the entire operational state of this vast system.
Yes. Whereas a dense paragraph of rules just tangles it up.
Okay, I want to ground this mechanical reality of the AI even further. There's an analogy from Emmanuel's piece that I think really clarifies what is happening to the AI's processing power here.
The chef analogy.
Yes, the chef analogy. So imagine you are hosting a really high-end dinner party.
Okay.
And you decide to go all out and hire a world-famous Michelin-star chef. You bring them into your kitchen, you are paying them an absolute fortune, you say, make us a wonderful meal.
And obviously the chef has immense capability and a vast repertoire of culinary knowledge.
Right, but then you don't leave the kitchen. You literally just stand over their shoulder and you start bombarding them with constraints.
Oh.
You say, Martin has nut allergies, so definitely no nuts. And Lucy loves duck, so you must include duck. Oh, and the apples in the yard are ripe. You absolutely have to feature those.
You're just micromanaging.
Exactly. You just keep adding requirement after requirement.
Well, the chef, much like the AI model, desperately wants to be helpful.
They want to please you.
Right. They want to fulfill your requests. But every time you add one of those rules, you are drastically narrowing their search space.
Boxing them in.
You are putting a literal fence around their expertise. And Emmanuel introduces the imagery of a heist movie here to explain the mechanical toll this actually takes on the system.
A heist movie.
Yeah, imagine that same kitchen is now filled with those red laser beam motion detectors, from a bank vault in a spy movie.
Okay, I can picture that. And your constraints, so like no nuts, must have duck, use the apples, those are the lasers.
Exactly. The chef now has to spend all their time and energy dancing around these beams like some sort of ninja acrobat, just trying to get from the stove to the fridge without tripping an alarm.
Which means we are talking about cognitive load.
Yes.
Or, in the AI's case, compute.
That is the core mechanism right there. The model only has so much processing power compute available for a single generation.
Right.
If it is forced to spend, say, 90% of its compute dodging your lasers making, absolutely sure it doesn't violate any of your micro constraints.
It has almost nothing left.
Right, it only has 10% of its compute left for the actual creative task of cooking the meal.
So they aren't even cooking anymore. They are just surviving your rules.
Yes.
You're going to get a meal that technically meets your criteria, like it has duck, apples, and no nuts. But it's going to be diner food.
Definitely.
It totally lacks soul. It lacks the cohesive flavor profile you hired the Michelin chef to create in the first place.
It is the culinary equivalent of the 2D Face and Whole app.
Oh, man. Yeah.
Technically accurate, but aesthetically terrible. If you had just given the chef basic, high-level intent saying something like, "We'd love a light poultry dish focusing on seasonal fruit, have fun."
They would have used all that compute to make a masterpiece.
Exactly. They would have utilized all their compute to produce something truly extraordinary.
So what does this all mean? It means for you listening right now, when you are sitting at your keyboard typing out a prompt, you are the annoying party planner.
You are.
And the AI is the chef. Every time you try to dictate exactly what to do and exactly how to do it, you are throwing laser beams into the kitchen and completely draining the model's processing power.
We really need to focus on goals, purpose, and intent. And this applies incredibly heavily to writing software, which is Emmanuel's primary focus in the piece.
Whoa.
Right. The more you tell the AI exactly how to structure the code, the worse the code will actually be.
Okay, hold on. Let me stop you there.
Sure.
Because if I'm building, say, a highly secure banking application, I can't just tell the AI, make a banking app that works well and go grab a coffee.
No, definitely not.
That sounds like a recipe for a massive compliance violation or a data breach. There has to be structure. I can't just cross my fingers and hope the chef inherently understands financial security protocols.
And that is a really critical distinction. It is exactly where Emmanuel introduces a crucial two-step framework for operating these models.
Okay, 2 steps.
He divides the workflow into planning versus implementation.
I see.
Everything we just discussed, getting out of the way, giving high-level intent, avoiding micromanagement, that applies strictly to the planning stages.
So like the architectural phase of the project.
Yes. The models available today are incredibly sophisticated if you give them a clear understanding of your high-level goals.
Like the compliance requirements for that banking app.
Right, the compliance requirements, the user experience you want, and the overarching intent. They can actually plan the architecture better than a human can.
Wow.
You give them the flexibility to be the master chef during that planning phase.
But then once that master chef has generated that brilliant high-level plan, the strategy completely flips.
Completely flips. You do not hand that massive abstract architectural plan to a single AI agent and say, "Go build this."
What happens if you do?
If you do, the model will hallucinate, it will lose track of variables, and it will just fail.
Here's where it gets really interesting. Instead of doing that, you take that holistic plan and you basically shatter it.
You break it down.
You break it down into extremely detailed, highly granular pieces. If we are talking software, you break it into epics, then tasks, then subtasks.
Emmanuel calls these individual units beads of work.
Beads, okay.
And this brings us to the second food analogy from the source, which perfectly contrasts with the master chef idea.
Right.
When you move to the implementation stage, when you are having AI agents actually write the code based on the plan, those agents do not need to understand the big picture.
Right.
In fact, you actively don't want them to. They are no longer the master chef. They are the short order cook in a busy diner.
I love this analogy. The short order cook gets a small paper ticket slammed on the rail,
Right.
and the ticket just says, pastrami sandwich, hold the mustard, extra pickles.
That's the bead of work.
That's the bead. And that cook doesn't even need to know the diner's quarterly revenue goals.
Nope.
They do not need to know how to bake the cherry pie for dessert.
Not at all.
They don't need to know the overarching architecture of the restaurant. They just need to look at the ticket, put their head down, and execute that one specific task flawlessly.
You use a super smart, highly capable AI agent, but you put blinders on it.
Blinders on.
You give it narrow, highly specific marching orders for execution.
Yeah.
A single function, a single script.
The dichotomy there really solves the problem of scale, doesn't it?
It does. For planning, broad intent, immense freedom, zero micromanagement.
And then for execution, extreme detail, zero ambiguity, hyper-narrow focus.
Exactly.
That makes a lot of sense when you are building something completely new from scratch.
Yeah.
You start wide with the plan, you narrow down to the beads, and you execute. I'm thinking most people working in software or even content creation, they aren't always building shiny new things.
They're fixing old things.
Yeah, exactly. How does this philosophy apply to massive existing projects? Emmanuel talks about brownfield projects, right?
Yes, those terrifying legacy code bases that already have millions of lines of code.
Where some of it was written like a decade ago.
Brownfield projects are actually notorious for breaking AI models.
Why is that?
Well, if you approach a brownfield project with the wrong prompting strategy, the AI will fail spectacularly, usually by writing code that conflicts with the existing architecture.
Because the human instinct is to just give the AI all the context. You think, I needed to understand how this old app works, so you just dump the entire code base with all of its tangled internal implementation details straight into the prompt.
And by doing that, you completely clog the AI's context window.
Let's define the mechanics of that context window for a second, because it's really vital to understanding why the model fails here. The context window is essentially the AI's short-term memory, right?
Yes. An AI generates output by predicting the next most logical piece of text, the next best token, based on whatever is currently sitting in that short-term memory.
Okay.
It constantly looks at the context window and calculates the probability of what should come next.
So if you fill that short-term memory with thousands of lines of irrelevant, deeply specific code from like 2018.
You are forcing the AI to make its predictions based on outdated, hyper-specific logic.
You are flooding its analytical space.
Exactly. And Emmanuel uses a very vivid analogy for this, too.
Oh, what is it?
He says dumping the whole code base into the prompt is like forcing the AI to look at a massive landscape, but making it look through a highly zoomed-in telephoto lens from very far away.
Oh, wow. So it can only scan a tiny microscopic portion of the scene at a time.
Right.
It's panning left, panning right, just trying to stitch together a coherent picture of a mountain while only being able to see like a single blade of grass at a time.
It wastes all of its cognitive compute trying to hold these irrelevant internal details in its memory.
So the mechanical solution must rely on that same underlying philosophy we talked about earlier. Get out of the model's way.
It does. The specific technique here is compression.
Compression.
You take that massive sprawling code base and you compress it into a very short, highly focused specification document.
And what actually goes into that compressed document is the real secret sauce.
Yes.
Because you only include the interfaces and the behaviors.
Exactly. You focus purely on the inputs and the outputs, what the system does, and how the different parts connect to each other.
But you completely strip out the messy middle.
You ruthlessly edit out the internal implementation details.
Right, because the AI doesn't need to know the specific math of how a 10-year-old function calculates a variable. It just needs to know that the variable exists and what it connects to.
And when you feed that compressed specification document to the AI, it easily fits within the context window.
So suddenly, that zoomed-in camera lens we talked about zooms all the way out.
The model can finally see the entire forest. It comprehends the full totality of the project, the overarching architecture, and what you are fundamentally trying to achieve.
Because its short-term memory isn't bogged down by all that irrelevant code?
Right. Its predictive token generation becomes incredibly accurate.
You have given it back its degrees of freedom to actually explore and solve your problem.
It always comes back to cognitive load.
It really does. Whether you are asking it to swap a face on a photo or port a massive legacy code base into a new language, the rule remains exactly the same.
Stop forcing the machine to navigate your irrelevant laser maze.
Yes, it's about respecting the architecture of the tool you are using, rather than just forcing our human delegation habits onto a neural network.
Which brings us to one final, incredibly practical, and frankly kind of sneaky trick from Emmanuel regarding constraints.
Oh, right. Let's say you are back in the kitchen with the Michelin-star chef, and you really, truly do have constraints you absolutely need to enforce. Like, Martin actually does have a severe nut allergy.
Right, you cannot avoid that constraint.
You can't. The trick here is timing.
You wait.
You just wait. You let the chef do their thing first. You let them conceptualize, brainstorm, and build the brilliant overarching plan with total freedom. And then, only once the masterpiece is fully planned out and the heavy cognitive lifting is complete, you poke your head into the kitchen and say, oh, by the way, Martin has a nut allergy, so let's just swap out that one ingredient.
And, I mean, the chef will probably roll their eyes at you.
Oh, definitely. It is an annoyance.
But because the foundational architecture of the meal is already established, the AI doesn't have to spend its precious compute designing around the laser beam from the start.
It just makes a targeted substitution.
You get the masterpiece, and Martin doesn't have an allergic reaction.
It is such a brilliant way to hack the system's compute limitations.
It really is.
If we synthesize everything we've explored today, the core lesson is a massive paradigm shift in how we manage artificial intelligence.
Absolutely. Getting the absolute most out of these incredibly powerful models is not about micromanaging every variable.
No.
It is not about writing the longest, most restrictive prompt possible to build guardrails.
It is about mastering the art of high-level intent.
It is about clearly defining the destination and then having the wisdom and the restraint to just get out of the model's way so it can map the most efficient route.
We really have to unlearn the instinct to control the process and learn to trust the architecture of the model to do the heavy lifting for us.
I couldn't have said it better myself.
Well, thank you so much for joining us on this deep dive.
Thanks for having me.
We've covered a lot of ground today for you listening, from the bizarre results of face-swapping apps to short-order cooks executing code to the mechanics of updating legacy code bases. But before we go, I want to leave you with one final provocative thought to mull over. Something that wasn't explicitly stated in the source material, but that has kind of been hovering over this entire conversation.
What's that?
Well, we've established that these AI models are rapidly getting smarter, right?
Yes.
And their ability to plan and create actually thrives when we give them fewer instructions.
They do their best work when we back off.
Right. So at what point does our role as creators shift entirely?
Oh, I see where you're going.
If the machine's architecture is fundamentally better at the overarching planning phase than we are we eventually going to stop being creators altogether?
That's a huge question.
Do we just become evaluators of the AI's own self-generated goals?
Oh, yeah.
Where exactly does human artistry fit in when the machine finally becomes the undisputed master chef and we are just the ones eating the meal? Keep exploring.